Cooperate. There we go. Alright. So you guys have any questions from homework? A little early morning crew. Do you guys remember what we're talking about?
Yes.
Alright. I appreciate the honesty. You're trying to find a question?
No, I was.
Alright. So there's no questions. We just have a little bit to finish up in section 8.2.
Wait, I do have a question. 70 on 7.3.
Oh yeah. This one here with the x cubed over stuff?
Yeah.
Just to cut to the next step, you can, the way it is, what can you do with the way it is? The two fractions, do they have what they need? Alright, let me write it down. I'm trying to write less stuff. Alright, what can you do with those two fractions? That's the one, right?
Yeah.
You can put them together. Because they have
Combined.
an LCD. They have the same denominator. So then you can just say it's this guy minus that guy all over the same.
Oh.
Now you're not done. Because once you put fractions together, the last thing you check is, can it reduce?
Yeah.
And of course the top is what form? Cubes. And guess what this guy's going to be? The big guy.
bigger.
Remember I told you, whenever there's a cubes in one of these reducing problems, some trinomial could very well be the big dude. So factor this guy, little dude, big dude, and that should be the big dude. Does that make sense?
Yeah. It should be the parentheses
Yeah, so the top will be this, and I'll bet you anything that this will be that. Yeah. Is that cool? So that one, on one level, seems too easy, but the whole point of that problem is to remember how to factor cubes. Really.
I thought you were just cancel out the x's. I was like,
Oh, no. You can't start breaking into subtraction. Yeah, division is not that powerful. I got some more people. Even more people. Anybody else have questions from homework? You guys remember any homework you've done? All right.
So behind.
This is Tuesday is our class is Monday. I understand. Okay. So last time we made it a decent way through section 8.2. 8.1 we've done a lot, and there's no question. So I'm hoping domain and range and all that kind of stuff is okay. So just to let you know what's happening in the near future, the next test is next Wednesday. The next quiz will be tomorrow. Oh shit. And it'll be on the rest of chapter 7. The last quiz we did went up to 7, see if I remember correctly, 7.2 only, I think. So this quiz will be 7.3 through 8.1. Let's see. Final is closer than you think. Oh my God. Right?
Right after the next test.
Yeah.
Is that week after? Yeah. Yeah.
All the birthdays on the
Wait.
27th.
The week after.
Yeah. It can't be until finals week. Next week is not finals week.
No, it's the 24th.
I can't remember it off the top of my head. 24th?
But I forgot
Sure.
what time.
Sounds good.
I'm sure it's like super early.
Oh, it's you for the final exams and everything.
Yes, exactly. So the day after the next test, Thursday the, what is it, 19th?
Yeah.
Will be review for the final. The Math Study Center has a review workshop too. I have to look up the day and the time if you want to go to that also. But I'm going to give a practice final. That last day is going to be just for final review.
Did you say we were going up to chapter 10?
Yeah, we're going to do a little bit of 10. Yeah. I think, was there anything else I wanted to say? Blah, blah, blah. No. Okay, so the main thing for the immediate future is this. Holy crap. The semester went by like that. I feel like let's just put the syllabus up yesterday. Okay. So that's for any questions? Are we all good to move on? Alright, so let's do this. Let's finish up chapter 8. Actually, let me do it on the board here. Let me not kill myself. The last little bit of chapter 8 we got to figure out is application problems and midpoint formula. Let me do part of that up here on the board. Now, if I only give you one dimension, I always love saying that because it sounds all science fiction, but it's just this. This is one dimension. And I ask you how far apart two things are. Like, how far is -2 from 1? 3. Can you figure out what is the middle point? What's the midpoint between this point and that point? What's the midpoint?
-0.5.
Yeah, how'd you figure that out? There you go.
I just went 1.5.
Where did 1.5 come from?
Well, I actually did it on there and then just was confident that 1.5 is half of 3.
Yeah, visually it kind of makes sense. I like it. But to develop some kind of an idea to attack things, I heard a good word, I think you said.
Divided 3
Divided by 2.
Divide 3 what?
by 2.
By 2, exactly. So you see how far apart they are and then divide by 2. Which is really taking the average. Think about it. In a way, so if you add them up and divide by 2, that'll actually work the same way, to be honest. But if you find out how far apart they are, they're 3 apart, divide by 2, that gives you 1.5. That's not the midpoint. You use that to move, like Nathan said, 1.5 over, so the midpoint would be right there, -0.5. So a little bit more general way to do that is to take the average. It makes sense. How do you find the middle of any two numbers? You take the average. That's how you find the middle of any two numbers. I love it. So another way to do this, because this is kind of like a 2-step process, which is good, but we're about to step into 2 dimensions, and I want a more direct way to do that. Right? So I always just take the average. So how do I take the average of these two numbers?
You add 1 and -2.
Good?
And then you divide by 2.
Because there's 2 numbers. I love it. So -2 plus 1 is -1. There you go, -0.5. That's the answer. A little more direct way, right? You don't have to do a 2-step process. I like it. So let me stop there for a second. How's that? You should know to find the average of any two numbers, to find the middle of any two numbers is just the average of those two numbers. I like it. Cool. So why am I spending so much time on this relatively easy problem? Because now we're going to go into 2 dimensions, which gets a little bit hairier. But the beautiful thing is, it's the exact same idea. I just have 2 directions I can go. So let's see a problem like that. I love this. All right. So everybody got this here? Poor little dude. So now I'm saying something like this. So if I have the points, this guy here, this is the point -3, -2, and the point, let's say, 1, 3, and I want to know the midpoint. This is a little bit more difficult, right? If it's just on one line straight across from each other, or even up and down, that's easy. I just take the average of those two numbers. These aren't two numbers, these are 2 points. Shit. But again, how did they do this? What we just did over here was all on what axis? What axis is this? X-axis, because it's going left and right. I love it. So what would be the midpoint of these two numbers? What do you got, Jeff? 5 and 3. What's the midpoint? 4. I love it, right? You can, that one's easy. But again, you take the average, 8 divided by 2 is 4. I love it. So if it's only X and only Y, easy as hell. Just find the middle between us, easy. But now I'm at a diagonal. The beautiful thing is you just do what we just did all at once.
Yeah, sorry, that's what I was going to say. You should do what you did over there just twice.
Yeah, exactly. So for the X, you find the X average. For the Y's, you find the Y average. So what's the average X up here?
-2.
Make sure that you... So the midpoint, here's the midpoint formula. The midpoint formula is average X, average Y.
So is it -2 plus 1?
-2.5.
Yeah, to get the average X, what's the average X?
-2.5.
How do you find it? -3 plus 1
-3 plus 1.
divided by 2.
That's what I did.
They stopped there for a second. Is that cool?
Yeah.
That's exactly what we did earlier when I only had the X-axis, but now I just focus on the X, get the average X, get the average Y, and together they're the average point. They're the midpoint.
-2, 2,
Let's find out. How about the average Y? That would be
3, and -2.
so you get -2 divided by 2 is
-1.
-1. 3 minus 2 over 2, 1/2. So -1.5. That's going to be the midpoint right there. That's the midpoint. Yeah, there you go. -1.5. That's the midpoint of that line. So it's almost too nice to believe. You just average the X's, average the Y's.
Oh.
So if you want an even better formula than this, to be honest, if I call this x1, y1, and x2, y2, it would just be add the x's, divide by 2, add the y's, divide by 2. That's how you get the average of those, right? So that's the full-blown midpoint formula. Kick ass. So you guys do this one. Oh, I need, here we go. Ooh, yuck. Do that in a bit. Either way is fine. It's just graph and it's easier to say. If you have to graph, easier on the graph. Yeah.
Oh, dang it.
So very often we like kind of recipe-ish ways to do things. So this is just plug and chug. So how do I find this first one?
5 plus 3 over 2?
Yeah. Add the x's, divide by 2.
8/2.
Add the y's, divide by 2. Yeah, be careful. 2 plus -6. So it would be
-4?
good. So this will be 8/2 is 4.
And
-4/2 is
-2.
-2.
12.
Let me stop there for a second. This is nice, right? Let this be nice compared to some of the other stuff we've done. Yeah, can't believe it's this nice. When you step up in dimensions, normally things get harder. This is just like, oh, you got to average both of them. Okay. So if I was in 3 dimensions, I would average all 3. Big deal. This way, that way, and then out. That's 3 dimensions. The world we live in. It's beautiful. I don't care how many dimensions you got. This is how you can do it. We'll just stick with 2 dimensions. So this one would be
1/2. Well, minus.
Oh. Yeah.
divided by 2. That's the average of those, right?
Okay, so 6.
-6 over 2.
And then -7
Oh, wait.
minus 2 divided by
Oh,
2.
okay.
Stop there, yes.
So, is that the same as saying 1/2 minus 7/2 combined times 2 over 1?
Well, times 1/2, actually. Divided by 2 is times 1/2. If you have to do that. Right? Division by 2 is the same as multiplication by 1/2. Division by 2 is not the same as multiplying by 2. So here, what do I get on the top? 1/2 minus 7/2 is
Oh, because of
Six halves.
-6/2, which is,
-3. -3.
so again, -3/2, comma.
Oh, so you leave it -3/2?
Yeah, what could it be? Well, you could make it -1.5.
Yeah.
Sure.
Okay.
Or -3/2. I made these decimals because I was graphing them.
Oh, okay.
So when I graph, I want to make it a decimal so it's easier to think about.
Okay.
So if I said graph, 12 over 7, you're like, oh shit, make it a decimal.
Again, this one is 1/2 minus 7/2 over 2. All
So
over,
what's 1/2 minus 7/2?
6.
-6/2,
Yeah.
which is -3
Um,
over 2. That's still there. It's just whatever that is, put it over 2. That's what that says. Nathan's point's good. If the top was still a fraction, I got to divide by 2, I just write it as times 1/2 so I can see it better.
Yeah, I just forgot it.
Yeah. And then over there I get,
Negative 4.5.
I love it, kick ass. So then I go to 1.5, -4.5, if you had to graph it. So I would take it either way. You look, second.
Only for graphic.
I just made a decimal so it was easier to think about where to plot it. If they want you to graph it, you can make it a decimal. Or leave it a fraction, that's fine. Yeah, is that alright? You don't like having too many options? Just be one serial to choose.
Even on a graph, you could still make it -3 seconds.
Yeah, but I'm just saying in general, if I had 17 over 4,
You can always switch.
you want to switch it over to something easier to think about. Yeah, cool, I like it. Alright, so that, just trust in this. The biggest mistake I see is people start to subtract because I think your brain goes back to y2 minus y1. It's not slope. It's not slope at all. It's all about adding because it's averages. Averages require you to add things. So why is that minus? Because it's freaking minus. Yeah, exactly. So I am adding them. Okay, cool. That's one idea. The next thing, let's do this in the yellow book. It's on page 210. Blue book, I have no idea. What's up? Oh, thanks, man. Yeah.
You know what it is?
It says whiteboard. That's a little better, right?
I just hit the screen, when you watch the video, it's hard.
Gotcha. All right. So let's see what we can do with number 2 here. Suppose that the community college costs $46 a credit, some college somewhere, and the student fees are fixed at $100, right? So if you want to become a student at this college, I don't care how many credits you take, you have to pay at least $100. It's set. So $100, does it change? No. Now, if the person took 1 credit, and that's it, how much total money do they owe the college? 146. If they took 2 credits,
119.
yeah, so 1 credit would be the fixed cost plus $46 times 1. 2 credits would be what?
Fixed cost plus 46 times 2.
That's crazy. So $100 they got to pay no matter what, plus $46 per credit. So if you want to take 2 credits, it would be 146 plus 100 plus 46 times 2. Let me stop there for a second. This is the part that people skip when they're trying to construct formulas. Give your brain some actual numbers. That's what your brain craves, and you're like, that's what I crave too, man. And then just see what, if it was X credits, just follow the same pattern. What would it be? So if I didn't know how many credits, X credits, what would the cost be?
100 plus 46 times X.
Exactly. What do I keep doing when I tell you credit? I keep multiplying 46 by it and then adding it to 100. Stop there for a second. This is the classic linear function problem. It's like, to get a plumber to your house costs whatever, plus so much per hour, right? Fixed cost plus so much per hour. This is fixed cost plus so much per credit. What does 46 act like?
8.
What does 46 act like? Looking at this visually, graphically, what would 46 mean?
M.
M,
Yeah.
otherwise known as
Slope.
slope. Are you guys cool? Because that's just mx plus b. I wrote the b first, but who cares? That's just mx plus b. So remember, A2 is all about linear functions. So they're trying to give you situations in the real world that could be modeled using linear functions. Another way to say it is using lines to predict shit, right? So if I wanted to take 18 credits, what's it say? Let's do part B. Do part B. Don't say anything out loud. Make it 16, yeah. Alright. So this can really be written more functionally as C of x. So I use C because that means cost, right? So C of x is 100 plus 46x. So what's C of 16?
100 plus
736.
100 plus
736. Yeah.
46,
Oh, times 16.
6 times 16, but you just plug a 16 in, right?
736.
So C16, once you do all this work, you get 736?
Yeah. No. Yeah. No. 46 by 16, 736.
All right.
Plus 100,
So 100
836.
plus 7,
36.
36.
836.
836. Woo! Alright, that was simple. Okay. So then I'm going to do this problem. I'm just going to put the whole damn thing in my calculator, right? What does this mean?
That if you take 16 credits, it's going to cost you $836.
Cool. So how do you think I want the answer written?
Dollars.
Yeah, units. Gas. So for 16 credits, Costs $836. Cool. Look at the next problem real quick. Why do they need to say this? Why do you read that real quick and familiarize yourself with the LP and TR? I'm not asking you specifically, but why would they possibly have to say something like that? Let me give you an example. Say you have a favorite fish in some pond somewhere, and you see it's like 2 inches long now, but every week it grows an inch. Right? So that would be plus 1x. Is that cool for every week? So you get 2 plus 1x is the length of the fish. Now, if I put in there, okay, let me wait 800 weeks. How long will that fish be? 2 plus 800 times 1 is 802 inches long. And then if you wait 8 million weeks, that fish is eating Manhattan. You got a weird science fiction thing, right? Because what the hell? What's my point? Sometimes linear functions only work for so long. So how confident? Up to what year do they think this will work? What this equation works up until what year? 2005 plus 7 years is 2012. I heard somebody say it earlier, but I want to make sure everybody's on the right page.
So that's a greater than or equal to, so it's 2012 and farther.
No. It's 0 less than t, less than or equal to 7. So it goes up till 2012.
Okay.
Cool. And it stops there. They're not sure after 2012 the equation might change. Okay, maybe. So like population growth of the country, a single function can't possibly work forever because things happen in that country. Right? Especially way back when we had plagues and shit. Things happen. Okay. So so P is 0, what the hell would that mean? What is P 0?
Beginning.
Whatever you see.
What is P of 0, just number-wise? Because it says evaluate P 0. What's P of 0? What would you do? What's 0? What do I do with 0?
7?
Yeah, it's going to be 4 times 0 plus 7. I'm just plugging a 0 in for t. Is everybody cool with that? So this is just normal function stuff, but with real-world stuff that it's modeling. So I get 7. What the hell does that mean? What's that mean? What's the 0 mean? What year are we in? Don't say year 0. In year 0, there.
2005.
2005. Good. In 2005. Keep going. What's 7 mean?
There were 7 wireless households.
I don't think so. Right?
7%.
I think we were better off in 2005.
7% of wireless households.
Percentage. Yeah. 7%
Of households.
of households had wireless connections.
Yeah.
Is that cool? So in 2005, 7% had wireless. You guys with me?
Yeah.
You have to be really careful about T years after 2005, so you understand what T of 1 means, T of 3, whatever. So what would this, how about P of 1?
2006. Oh.
Good, so I know in 2006, good. So what do you get when you plug a 1 in?
Oh,
4, 1.
Careful, I'm adding.
11.
Yeah, 4 plus 7, 11. So in 2006,
11%.
11% had wireless. Did it work? Well, no, but oh well. I'm thinking back to the 80s, we had war games. Sorry. And then, of course, P3 would be the same idea. Are you guys understand?
19.
Yeah, you would do, 12 plus 7, 19, we get 19%. Same idea. I like it. Cool. I like this question.
Slope.
So slope is a good start, but I need physical explanation. Slope is not specific enough to this question. It's all about percentages of households that have wireless, T years.
The change in percentage.
Yeah, so what would the slope be? Slope is change in y over change in x, right? And what's acting like y here? Now, stay with me now. This is where things get interesting.
P of O,
P is acting like y. Is that right?
Y,
Normally, what would be here? Y equals 4x. So P is, so this is the change in percentage, and what's acting like x?
Huge.
T, over the change in time. It's how much the percentage changes over time.
4.
Do you guys see that? If you write the slopes units out, you can interpret what the hell it means. So it's percentage per year. So every year we were getting what? Every year there's going to be
more.
how much more? 4%.
Yeah.
Another 4%. Another 4%. And another 4%. And another 4%. Maybe. You guys kind of with me? I think the first part of some of this was a little too easy, so we guys tuned out, and then all of a sudden it got more interesting at the end. But if you just write, you can see how I attacked that. I looked at what was acting like y, and I put its units down. Y is percentage. X is the t variable, which is years. Percentage per year. Bam! That gets me going in how to explain what the hell the slope is. Put the units down. This is kind of important.
Yes.
I like it.